It means that you're leaping over time in an extraordinary, almost a way that transcends our grasp of what time is.
They say that they don't move in the speed, in the way that we move. Instead of, we travel so many miles per hour.
Yeah.
But instead of this, they bend distance. They do not bend time, they bend distance, space itself. Like if you'd take a string, this end and this end, and bend them directly together. If you would flip the switch, the end just comes together, and you're at that spot. As strange as it seems, as hard as it is to believe, these people told me that our government, our own government here on this earth, could travel at any speed far greater than the speed of light right now. They have the means, they have the ways, if they could control the gravity itself that would keep from crushing or disintegrating the objects from which our government will move. They have the ways to move it, but they cannot control it. These people do have a way to control it.
So up until now, when we've examined the requirements to travel these distances, we've always had to consider the problems of traveling at a speed near the speed of light. This poses problems with propulsion, navigation, fuel capacities, and even when you consider the effects of acceleration on space-time, which include time dilation, mass increase, length contraction, and a whole host of other things, it quickly becomes evident that this type of travel would require a level of technology that man has not yet achieved. The truth of the matter is that traveling these distances does require a level of technology that man has not yet achieved. But it has nothing to do with flying in a linear mode near the speed of light. We know that the shortest distance between 2 points is a straight line, so in our universe we've always assumed that the fastest way from point A to B was to travel in a straight line at the speed of light. Well, the fact is that when you're dealing with space-time and you enjoy the capability of generating an intense gravitational field, the fastest way from point A to B is to distort or warp or bend the space-time between point A and B, bringing point A and B closer together. The more intense the gravitational field, the greater the distortion of space-time and the shorter the distance between points A and B. Most of us think of space-time as the void or as nothing. And remember, it wasn't that long ago that man considered the air in our atmosphere to be nothing. Yet with time, we've become aware of the elements and properties of the air in our atmosphere. Well, indeed, space-time is an entity, and one of its properties is that it can be distorted or bent by a gravitational field. We know that gravity bends or distorts space-time and light by virtue of the fact that we're able to see stars which we know should be blocked from our view by the sun. Referring to the graphic here, the solid line denotes the position of a star that's located behind the sun, and the dotted line shows its position as viewed from Earth. This is made possible because the sun's gravitational field distorts the space-time and light around the sun, allowing us to view stars which should be hidden from view. We know that gravity distorts time by virtue of the fact that if we take two identical atomic clocks and keep one at sea level and take the other one up to a high altitude, when we bring them both back together, they reflect different times. The difference in this passage of time is caused by the fact that a gravitational field weakens the further you get from the source. So the atomic clock which was taken to the high altitude was exposed to a less powerful gravitational field than the clock which we kept at sea level. The effect of a gravitational field on space-time is something that we've been able to observe, but not to experiment with. This is due to our inability to generate a gravitational field. And up until this point in time, great mass such as a star, planet, or moon was the only source of a discernible gravitational field that we're aware of. So just as the gravitational field around great mass such as a planet distorts space and time, any gravitational field, whether naturally occurring or generated, distorts space and time in a similar manner. Now, the great benefit of generating an intense gravitational field is not only can you turn it on, but you can turn it off. If we refer back to our original illustration of space-time distortion, we can see that when we generate an intense gravitational field, we can distort the space-time and in turn the distance between the point where we are and the point where we want to be. We can then position ourselves at the point where we want to be and then stop generating the gravitational field, allowing space-time to return to its natural form. In this manner, we can travel great distances with little linear movement. And this is how space-time distortion translates into reduced distance. Now back to our original question, how is it possible to cross the vast expanses of space required for interstellar travel? without exceeding the speed of light. This is accomplished by generating an intense gravitational field, distorting space-time and allowing you to cross many light years of space in little or no time and without traveling in a linear mode near the speed of light.
How do these spacecrafts work?
It's a very, very fascinating science because...
Don't be too technical.
I'll do my best. As Carl Sagan often has said, it's not logical for us to even consider traveling to the nearest star system due to the concepts of linear travel. It doesn't matter how fast you go, and if you can approach the speed of light, you still have to go from point A to point B, and whatever that distance in light years is, it takes way too long for us to consider feasibly going there and coming back. Well, if you can eliminate some of these concepts, is what is apparently happened with these craft. What they do is they're able to generate their own gravitational field, and without getting too technical, they are able to manipulate time, which is something we have been very much aware of for a couple of decades at NASA, is that gravity slows down time in contrast to what we normally think of as 60 seconds a minute and so on. There is no constant relative to that except in one place in terms of the gravity. In other words, the gravity field is the same on the surface of the Earth, but when you leave the surface of the Earth, strange things begin to happen in terms of time. Fact is that time speeds up the further away from a gravity influence you get. Well, these machines create intensified gravitational fields, which in effect slow down time as we see it, and are able to cut down on the amount of time it takes to go from point A to point B. The other point is that if they're able to focus a gravity field on another point, they're able to stretch or pull together points A and B as if you view, let's say, space as like a waterbed. If you put a bowling ball in the middle of the waterbed, the bed kind of wraps up around the ball. Well, this is very typical of what happens in space. If you create an intensified gravitational field, you warp the distances between the two. In other words, shortening the distance between A and B, making the whole concept more feasible. And that's, in a nutshell, really how these things operate, is by warping space and time and getting into some real interesting astrophysical sciences. It interprets into a much more feasible method of travel.
So it's not like getting from A to B, the old linear travel. It's,
exactly.
The technology is kind of antimatter.
Well, there are some systems that use what is referred to as an antimatter reactor, which is an extremely powerful system. It uses super heavy elements, well beyond those that we have been familiar with traditionally, like uranium. They are able to capitalize. Apparently, there's a low-grade B gravity wave, which is different than the atomic gravity that holds molecules together, that they're able to capitalize off that and amplify it. They use a series of amplifiers in order to focus it. It's a lot easier to focus 3 points than it is to just try to focus one. Typically, with a telescope, we'll try to focus one. What we've learned in deep space science, like in the SETI project, is that if you put one antenna here, one in Arecibo, and you spread these around the planet, you can actually focus 3 different points, get a much bigger telescopic view. Well, this is very similar to the types of things that they're doing with gravity waves.
So presumably they've taken some of these elements heavier than uranium down here, and we've now got them in our hands and they're being examined.
Now, that's another interesting phenomenon, too, is that we apparently have about 500 pounds of this, of the fuel, shall we say, the heavy gravity stabilized fuel, the systems that are used. How we got that is remarkable, because it only takes about 223 grams to operate one of these things. We don't even know how long. I mean, it's a lot longer than the average car will last, I'll tell you that.